So now that we've talked a little bit about what Java reactive streams are, let's talk about some popular implementations of the Java reactive streams API. And this will include Project Reactor and RxJava. We'll be focusing on RxJava in this course. And then in my course next semester, we'll be focusing on Project Reactor, and we'll cover it from a different point of view. So it turns out that the Java Flow API by itself isn't really very useful. It's kind of like a fork that has a chain attached to it, so you couldn't actually hold anything in it. It's like a wine glass that would dribble down your shirt when you tried to drink from it. It's like a key that has a flat top, so it would get stuck in the lock. So it's not very useful by itself. What is useful, however, is it provides the basis for an interoperable framework that can then be implemented by other popular reactive programming frameworks. And these would include, again, RxJava and Project Reactor. These frameworks, these implementations, enable the insertion of event transformer operators between publishers and subscribers. And that's really the secret sauce. There's all these other things that can be done between the point where a publisher emits an event by calling on next, for example, and a subscriber receives that event. You can have all kinds of other things between those. And you can think about it like a stream, essentially, very much like Java streams. And so what you have here is you have publishers that will generate events at a certain rate, and those events flow through a pipeline of so-called transformer or filter operators, and then the events are delivered to 0 or more subscribers, depending on who has registered to receive the events. So you can basically think of this again as something like Java streams, where there's a flow of events through a set of transformers or filters, much like the water purification system metaphor that we talked about when we were dealing with Java streams earlier. Now, reactive streams programs rarely use publisher, subscriber, and/or subscription interfaces directly, but instead they use classes that implement those interfaces. And depending on which framework you're dealing with, be it RxJava or Project Reactor, you will deal with a different set of classes. So we'll talk a bit about that. And you can read more about the differences between RxJava and Project Reactor at the link at the bottom of this slide. So let's first start by talking about some of the classes that are part of the RxJava API. And this, of course, is what we're going to be focusing on in this class. So we'll focus on those right now, and we'll just talk about the Reactor key classes just briefly for completeness. And so there's a mono class, which is going to complete successfully or with failure, and which may or may not emit a single value. This is basically like an asynchronous optional, if you recall the optional class, some of we've talked a bit about in our course. And there's a whole slew of examples of mono in Project Reactor in my GitHub account. There's also something in Project Reactor called a flux. And this emits an infinite number of events, which optionally complete successfully or with failure. And this abstraction supports back pressure, which is this concept of flow control, where you can dictate the publisher can be informed how many events to send before the subscriber needs to ask for the next tranche or the next chunk. And there's another bunch of examples of that at my GitHub account. Let's focus now on RxJava. That's really what we're going to be doing in this class in this semester. So the first class is single, which is very similar to mono from Project Reactor, in that it either completes successfully and it will emit exactly one item, hence the name single, or it fails and it doesn't emit anything. And there's a bunch of examples. We're not going to spend a lot of time looking at single in this class. If you want to learn more about single, I have other videos that you can look at. And of course, I have lots of examples in my GitHub repository. We're also going to be focusing most on observable and flowable. So observables are similar to fluxes in that they can emit 0 to infinite number of events, which may or may not succeed. And one of the things that observable does, it does not support back pressure. So it'll just take the data it gets from whatever source the data comes from, and it will push it through the stream as quickly as it can to any subscribers that may exist. And there's a whole bunch of examples of those. We will take a look at some observable examples. The next class, which is super important for our purposes, is called flowable. And this is very much like observable, except that it can support back pressure. So you can instruct the subscriber can instruct the publisher how many events to send before waiting for the next chunk, next tranche, as we call it. You'll see that one of the key classes we're going to focus on in this course is a variant of flowable, subclass of flowable called parallel flowable. And we're going to use parallel flowable in order to be able to get parallel processing, very much like parallel streams. And there's a bunch of cool examples that you can learn from to see how to implement programming assignment number 4. 2 more classes. There's something called completable, which will either complete successfully or will fail without emitting any value. It's very similar to the Java completable future abstraction if parameterized with a void. And then finally, we have maybe, which completes successfully or with failure, which may or may not emit a single value. And it's, again, very similar to an optional value of type T, much like mono was in Project Reactor. And as you can see here, RxJava has 5 classes where the Reactor framework only has 2 classes, and there are pros and cons to having more or less of these classes. I'll leave it to you to decide which approach you like better. They both give you more or less the same capability. So that's the end of the overview of some of the popular implementations of the Java Reactive Streams API. Again, we are going to focus on RxJava in this course, and then we're going to focus on Project Reactor in my course in the spring. And the main reason for that is that Project Reactor comes baked into modern versions of the Spring platform for doing web apps, so-called opinionated web apps. And Spring has a really cool support for something called WebFlux, which allows the abstractions to be used across network boundaries. So you can actually have asynchronous programming that crosses network boundaries. Since this class, this semester, is not focusing on network programming per se, we're just going to use RxJava. And then next semester, when we talk about network programming, we're going to talk about Flux in the context of WebFlux. You can actually connect clients to servers. Both programming frameworks work very, very similarly. And so once you know one, it's easy to learn the other.